Hello friends, this is the second part of the video of gas field Newton detectors. In the part 1 we have seen the general construction and working principle of gas field Newton detectors. Before going into the details of the Newton detectors, let's understand the different regions in which the Newton detectors can operate. So the part 2 of the video we are going to see is based on the region of operation of Newton detectors. So let's start the video. Here I have shown one graph on which on x-axis I have shown the voltage and on the y-axis I have shown the number of counts. Considering the dimension of the detector remains the same, what happens to the number of count if we increase the voltage is depicted by this graph. So if we increase the voltage in the region 1, the number of counts will increase, and we can see that if we increase the voltage in the region number 2, there is no increase in the number of counts, and in the region 3 we can see that if we increase the voltage, the number of counts will proportionally increase, and there is a limited proportionality exists between the voltage and the number of counts in the region 4, and region 5, if we increase the voltage, there is no increase in the number of counts, and in the region number 6 there is a breakdown or avalanche. So we can see the name of each region just below the graph. So we call the region number 1 as recombination region, region number 2 we'll call it as the ionization region, region number 3 we call it as the proportional region, region number 4 we call it as the limited proportional region, region number 5 we call it as the Geiger-Müller region, region number 6 we call it as the avalanche or breakdown region. Now considering a detector in which there is one anode and outer periphery is cathode, and we are giving a high voltage between the anode and cathode terminals. So if there is any particle coming from outside, for example neutron, that interacts with the gas, it will produce an ion pair, and that ion pair will going to be collected at the anode and the cathode terminal. But if the voltage level between anode and cathode is not sufficient, then some of the primary ion pairs produced will be recombined. So the same is happening in the region number 1. Hence we are not able to collect all the charged particles produced by the primary ionization. So this region is called recombination region. Hence if we increase the voltage, the number of ion pairs collected at the anode and cathode is going to increase. And now if we provide a sufficient amount of voltage level between anode and cathode, that no ion pair will be recombined in between, so that region we call it as the ionization region. So even if we increase the voltage, there is no further increase in the number of ion pairs collected at the anode and cathode. So now if we further increase the voltage between anode and cathode, then we'll move to the region number 3, where the primary ion pairs produced will have sufficient amount of energy that during their movement they will create the secondary ion pairs and will get the primary plus secondary ion pairs. So there is a proportionality between the applied voltage and the number of ion pairs collected at the anode and cathode. So that's why this region is called proportional region. Now if we further increase the voltage between anode and cathode, then there is a limited proportionality. There is not an exact proportionality between anode and between the voltage and the number of ion pairs collected at the anode and cathode. This is because the primary ion pairs will produce the secondary ion pairs, and secondary ion pairs will produce the tertiary, and this chain will go on further. But still there is not one-to-one correlation between the voltage level applied and the number of ion pairs collected at the anode and cathode. That's why this region is called limited proportional region. And further if we increase the voltage level, we'll move to the region number 5. Even if there is a particle from outside which is coming, which can ionize the gas, the complete gas is going to be ionized. So this region is called the Gigamolar region, and we can get the maximum pulse height from this region. And now if we further increase the voltage between anode and cathode, then even if there is no particle from outside is coming, the gas will the gas will automatically ionize because of the sufficient amount of voltage present between anode and cathode. So we'll never operate in this region, region number 6. We mostly operate in the gigamolar region, proportional region, ionization region. These three regions we generally operate, and we will see that different types of detectors will operate in different regions, but mostly in ionization region, proportional region, and gigamolar region. So we'll see the different aspects of gas filled neutron detector in further videos. Hope you like this video. Thank you.